So if I look at this circuit here, I'm going to kind of bounce around if you guys don't mind answering a couple questions for me. Um, let's see here. Let me start with Kate. So electricity, we're going to close this switch. Here's the positive end of the battery. So the electricity has how many paths so far here, Kate? Multiple paths or one path?
Multiple paths.
Okay. So you see where I'm tracing along with the cursor, right?
Yeah.
Okay, so I close that switch, right? There's basically a wire here, a wire here. Do I have any choice or do I have to go through this bulb?
You have to go through it.
Okay, so when I ask you, are there multiple paths or one
Oh,
path for this part, what would you say so far?
one.
Just one path. Now, when I get to this point, Kate, what do you notice?
Now you can go two ways.
Okay, and that's where we're getting this idea of a complex circuit. You have something that looked like a series. You have only one path. Thanks, Kate. And then something that very clearly, you've got a multiple paths. You've got this path with 3 light bulbs, and you've got this path with just 1 light bulb. And so you've got multiple paths. But even within just this piece right here, and I'm going to go over to Emily Larson, if I were to just focus on just these 3 light bulbs that I'm circling here, just those 3 alone, does that look like series or parallel?
Series.
Yeah, so you've got not only this thing, thanks Emily, this thing that looks series, but then it's next to this thing that looks parallel. And then you've got this other thing. And so to the uninitiated, to the folks who don't have confidence with this stuff, this can be totally intimidating, all right? So what we're gonna do here is we're gonna take this circuit and we're gonna basically transfer it into something that would look more like a circuit diagram that actually an electrical engineer or a physicist would be able to understand. So I'm gonna stop sharing my screen here. And this is where you probably wanna start jotting some stuff down on your, and I'm going to come over here, share the screen. Sorry about all the bouncing around. And all right, so, and Emily, since I'm seeing you on my screen, give me a thumbs up if you see my blue pen wiggling there. Okay, cool. So let's go ahead and tackle this. So what should this look like? I'm going to go ahead and draw my battery down here. We got the positive side and the negative side. And I'm just going off of the drawing that I just showed you. And so we come up, and I didn't focus too much on the values, so I'll write these here. You've got a 2 ohm light bulb here. And then we basically had 2 paths. And every time I do a squiggle, that squiggle represents a resistor. And resistors are just interesting things in the circuit that convert the electrical energy into something more fascinating. In this case, the light bulb turns it into light and heat. We had a light bulb hanging out down here that was 2 ohms. And then in this little stretch up here, I actually had 1, 2, 3 squiggles. Each of those squiggles was a 1 ohm resistor, 1 ohm resistor, 1 ohm resistor. And I want to make sure that everybody can see that. It's big enough. Okay, and then these guys came back together, and then there was 1 more resistor on the way back to the battery, and it was 2 ohms. So if I ever want to, in essence, figure it all out, and by figure it all out, I want to do voltage, current, and power at each resistor. You really have to just kind of take it a piece at a time, not get overwhelmed by any part of it, and just apply the rules that you know about series circuits and parallel circuits. And so there's a little bit of a skill to this, and the more of them that you do, the better at it you get. But what I would do is I'd first off, if I'm going to try and solve this complex circuit, you want to try and turn that complex circuit into something that looks simpler. Because if it's simple, then we're going to be able to analyze it. And as I look at this, all right, I'm going to focus in first on these 1 ohm resistors all bang, 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 one after the other. And I'm going to hope that I'm not interrupting you here, Addie. If I think about these ones in a row, does that look like a series or a parallel piece right there, Addie? Just that
A
piece?
series.
It does. And what do we know we can do to find the total resistance of a series circuit if it's a 1 ohm
You can
followed by a 1 ohm by, say it again?
add them.
Yep. So what I'm going to do is I'm going to start drawing some sort of simplifying diagrams, all right? So this piece up here, we're going to basically replace with an equivalent resistance of 3 ohms, all right? And this is where I need to manage all of my screens and make sure that everybody can see everything. And so the 3 ohm resistor is the replacement for those 1 ohm resistors. I still have a 2 ohm resistor hanging out down here. And so we're going to basically just collapse this thing down in a series of, and I'm sorry to put this, it's 10 volts on the battery, the power supply, I forgot that. So we're going to just collapse this down through a series of steps until it gets really, really simple looking. All right, now here's the problem. It still looks complex, and Addie, I appreciate that. I'm thinking Alliston's phone. You're on here as Alliston's phone. Is that you, Adam?
That's me.
Uh,
My phone's hooked up improperly.
Gotcha. Okay, Andrew, how are you doing, buddy?
Doing good.
Good. I'm sorry. I was trying to figure out who was in on the call there, and I remember.
Yeah, my phone has like 4 different identities.
It's okay. Don't we all? Andrew, listen, as we look at this, this still looks pretty complicated. I've got 2 here and 2 here and 3 and 2 here. If I just focus on this piece right here, does this look like a series or a parallel circuit, Andrew?
Which piece? The one over the other, or?
Yeah, the 3 and the 2 and the sort of the part that I'm.
Well, that looks like, I think that looks more like a parallel circuit.
It absolutely does. And so you can't just add the resistors there. This is where, so we're going to now take and collapse this, and we're going to use the resistance formula for a parallel circuit, which is this 1 over formula. So I get 1 over 3 plus 1 over 2. Now, fraction's a little bit ugly, so we're going to do a little bit of ugly math. I'm going to get a common denominator here, and that's going to be 6. So this would become 2/6, and this would become 3/6. And so what I end up with is 1 over RT equals, and this is a plus sign, 5/6. And this is something that, and this is the formula that we use just for parallel circuits. You have to remember that this is the inverse of the resistance. So we have to take and flip that number at the very end. So if I wanted to replace the 3 and the 2 in parallel, that is equivalent to having one resistor that is 5/6 of an ohm. So at this point now, I'm making my drawing yet again, but I am in essence, I'm simplifying it down, simplifying it down, simplifying it down. So what do I have here? So I've got my 10 volt power supply, comes out, got my 2 ohm here. This whole big parallel thing is now one resistor of 5/6 of an ohm. Then we're going to come.
Sorry.
Yeah, go ahead.
Do you not take the reciprocal of the?
Did I forget to it? You know what? Thank you, Kate. In all of my, I'm still getting used to looking at 7 different screens while thinking and talking about this. Kate, you're exactly right. I forgot to take the reciprocal. So this should be 6/5. And because I'm pretty sure you guys don't like fractions like I don't, 6/5, if double check me, that would be 1 1/5. So that would be 1.2 ohms. Kate, thank you. You saved me from a devastating mistake there. All right. So what we've done here, just to kind of recap, and I know Ethan, you were joining in there at the very, a little bit late. We started out with kind of a complicated circuit that we looked at on the simulation. And what we've done is we've worked through a series of steps to get it down to this. Now, at this splendid point in time, Ben, I'm going to come over to you. I've got a 2 ohm, a 1.2 ohm, and a 2 ohm. And it looks like what type of circuit here? Series or parallel?
Parallel? Series.
You've said both. You don't get to say both. How many paths does it look like I have for that
One.
draw? One. So by default, that has to be what type of circuit?
Series.
And the easy thing to do, if I wanted to find the resistance of that whole circuit, the resistance total, what would I do?
Add them up. So it's
Add them.
5.2.
Add them up. So I'm going to take those guys. I'm going to zoom this a little bit larger so you guys can see it a little bit easier. So you've got the 2 plus the 1.2 plus the 2. And just like Ben said, so what we've now got, oh, deep breath, is we've got that the overall resistance of this sucker is 5.2. Now, let's step back. Thanks, Ben. And let's see here. If I can come over to perhaps Nathan. If I look at the entire circuit, what else do I know about the entire circuit? Do I know the voltage or do I know the current, sir?
Sorry, I just realized I was muted.
It's
You know the
okay.
voltage.
I do. And so if I know the voltage, and what is the voltage for the entire circuit?
10 volts.
10 volts. So if I've got voltage and I've got resistance, what can I calculate, Nathan?
You can calculate current.
Okay. And so once we have, thanks Nathan, once we have sort of two pieces of that I equals V over R, that Ohm's Law puzzle, we can now go to town. So we're going to use I equals V over R. Sorry, I realized that was off the screen. And I'm going to do that for the total values. E total, R total, I total. And so the amount of current going through this entire circuit has to be 10 volts divided by 5.2 ohms. And if anybody has a calculator handy, I'd love to have a number there, because if I start doing calculator stuff, I'm probably going to lose my mind because I got too many things going on my screens.
It's 1.92.
And I'm going to live with that because I think that looks about right. So thank you there, Ben. All right. Now, what we're going to do is we're going to kind of take this all the way back to the original picture, but I'm going to pause for just a second. Any questions up to this point? Okay. So we're going to go back up to the original picture here, and we're going to think about, all right, so I have 1.92 amps. So I'm going to go over there to, let's do Ethan. Ethan, does all 1.92 amps of current, does all that current go through this 2 ohm resistor here?
Yes.
Yeah, because there's no other choice. There's only one option there. So I know that the current here, I, is 1.92 amps. Now, Ethan, here's the tricky part. When that current gets to this junction right here that I'm pointing to, and I'm hoping you can see that, the electricity now has two choices. It can go up this way through this branch or down this way through this branch. Which branch, the top or the bottom, is the easier path for the current to flow through?
The bottom one?
Because its resistance is what?
2.
Up here, the resistance is what?
3.
So in the back of your mind, we know that the current has to split, and we know that less current is going to go up here. All right, so we're not going to say what the current is in this part yet, okay? But we are going to come back over here, and Ethan, then I'll let you off the hook after this question. Once these electricity branches come back together, does all of that current have to go through this 2 ohm resistor over here at the end?
Yeah.
Yeah, so how much current can we put over here? We know it has to be what?
2 ohms?
Yeah,
Oh,
1.92. Yep. Okay, so brilliant stuff. So what we're going to do now is we're going to come back down here a little bit. We'll do a little bit of calculating because our ultimate goal was to figure out the voltage, the current, and the power at each resistor. So for the 2 ohm resistors at each end, the 2 ohms at the beginning and end, we know that we've got 1.92 amps going through a 2 ohm resistor. So I know the current, I know the resistance. And so if I know I and R, I should be able to find voltage. So I equals V over R. Rearrange that, you get V equals IR. Make that a little bit bigger for you guys. Sorry about that. And so I know that the voltage going to each of those 2 ohm resistors is just going to be 1.92 times 2. Double check me. I think that that's 3.84?
Yeah.
Okay. So I've got 3.84 volts at each of those resistors. A lot of things to keep straight here, trying to go slow enough to keep everybody from getting lost. So I come back up here to the picture. So I've got 3.84 volts here, and I've got 3.84 volts here. Now here's the beauty of this, guys. All right, if I were to zoom this out so we can see all these things at the same time. If I were to think about, hey, I've got 3.84 volts right here and 3.84 volts right here, there's a nice little rule about voltage. Voltage in a series circuit, what does the voltage have to add up to in this case here, guys? Anyone?
10.
It's got to add up to 10 because this looks like a series circuit. So if I've got 3.84 volts here and 3.84 volts here, to figure out the voltage right here, all I've got to do is say, all right, well, I know that 3.84 plus 3.84, that's going to give me 8, 16, 7.68. I got to take that away from 10.
2.32.
And Ben, I appreciate that very much. So what I've now just done is I've said, I know the voltage for this little critter, 2.32 volts. And for some of you, this is just like, oh, this is ultra confusing. Others, they actually really kind of like the puzzle aspect of this. Because now what I can do is I can say, well, wait a second. If it's 2.32 volts for this guy was really this. So I know that I have 2.32 volts for this. And then I can sit here and say, well, cool. If I know the voltage and I know the resistance, what should I be able to figure out?
Current.
That's right. We're going to get ourselves a little bit of current. So I'm going to now break this down and we're going to finish this guy off. All right. So for the top branch, all right, we said that this was a total of 3 ohms. That was my resistance. And then we said that the voltage was 2.32 volts. So the amount of current has to be 2.32 volts over 3 ohms, something a little less than 1. And I'm hoping one of my calculator having people will toss a number at me.
0.77.
I'll go with it. So I know that going through the 3 ohms, so up here, I know that there is 0.77 amps of current. How much total current did we know we had in the circuit? I think we knew that we had, that was the voltage.
Oh.
The total current we had was 1.92. So when we get to this part where it splits out, 0.77 amps goes up here. How could I figure out how much current goes through this bottom part?
Subtract 1.92 from 0.77.
Perfect. So if I wanted to think about now the bottom branch, you would literally sit there and say, hey, 1.92 amps minus the 0.77 amps is going to give me I want to say 2.5.
1.5.
Because I can't do my math in my head. Okay? And these problems are tricky, but we're almost there. So at this point now, and this is where I wish I'd drawn a little bit bigger for you guys. I'm super sorry about that. So I now know that through each of these 1 ohm resistors, the current has to be 0.77 amps. I know that down here, this guy has to have 1.15 amps. And because I know the current and the resistance, I should be able to find the voltage for each of these guys. Down here, I already know what the voltage is because here's the thing. I knew that when I went through this part of the circuit right here, this 2 ohm branch, it was 2.32 volts. So I'm going to use up all 2.32 volts going through here. And because these resistors are all the same, that 2.32 volts is going to get divided out evenly. If you don't believe me, you can sit there and figure it out because we do know that voltage is equal to current divided by resistance. So 0.77 is the current through each one of these guys. The resistance is 1. So the voltage, 0.77, 0.77, 0.77. If I added 0.77 together 3 times, should give me something very close to 2.32. Now, at this point, if I had been a little bit more organized, we would have had a table and everything would have been all neatly placed in there. But we now know the voltage, the current, the resistance. Should I be able to figure out the power for each of these things? I think we should. And so once we do all that, we would see that the power would give us a matching sort of view of what we are. I'm trying to share my computer screen because this has gone on too long and we need to call it quits. Ben, I'm seeing you. Can you give me a thumbs up if you see the circuit on the screen there? Okay. So if we look at this, and I have this going in, let me switch it around and go in conventional flow. So all of the electricity flows through this guy. All of the electricity flows through this guy. So these guys would have pretty big brightnesses. This branch right here definitely has a high resistance relative to this one. So it's not getting much current. Therefore, these bulbs are not very bright. This one gets a fair amount of current. And I think, given that we're trying to do this remotely, I have hit my maximum limit here in terms of what we're trying to accomplish. So let me stop